And again, I'm going to explain a little bit about what I do and about some interesting things happening in the world of measurements that affect everything that we do. Again, since I graduated here, I've been able to travel around the world for my company in disseminating measurement science and sharing with other people and learning from other people. I've had the opportunity to meet 3 Nobel Prize winning physicists. Let's see, Hall, von Klitzling, and now his name just went out of my head, with Stephen Chu, he won the Stephen Chu, Bill Phillips as well. So, again, so the opportunities that you get learning physics at IPFW can truly take you all over the world. It's what you learn and what you do to apply your education from here on out is what's going to make the difference for you. So again, my talk is on the pending, and it's still not entirely official yet, but we are looking at a redefinition of the International System of Units coming up in 2019, and that's what this whole talk is about. What's driving it, why, and what's going on with that. So, and also a Fluke's role in this position, in this whole process. So again, I work at the headquarters in Everett, Washington for Fluke Corporation. We're actually owned by a larger company called Fortive. It doesn't put their name as much out there, but Fluke is about $1.5 billion company. We've got people all over the world, manufacturing in Phoenix, in Salt Lake City, in England, in Germany, in China, and a little bit in India. So we're pretty much a global company here. So this is our headquarters building. And again, most people, when they hear about Fluke, they think about the industrial products, really rugged. There's some really cool videos if you ever go online about how people like to test our products. There's one guy who took his meter and got his car up at 60 miles an hour, threw it out the window, and it worked, and threw it off like a 100-foot cliff, and it worked, and went whitewater rafting with it, and it worked, you know. So that's what a lot of people know and love our Fluke products for. But I specifically work in the field of metrology. So what is metrology? It's simply the science of measurement, and it's a subfield of physics. As a matter of fact, a lot of physicists who won their Nobel Prize have won it for their work in metrology. Like the first American physicist to win the Nobel Prize, Michelson, if you read his award, it talks about the advancement of metrology for the measurement of the speed of light. So in this particular picture, this gentleman in here, this is a picture of one of the national metrology institutes in one of the Caribbean nations, I can't remember. But on this particular picture, I didn't bring my laser pointer with me, but and what he's doing is disseminating electrical voltage measurements, disseminating the volt, the ohm, and the amp for his nation. Every country has a national measurement institute to be able to disseminate measurements, and we'll explain a little bit why measurements matter a little bit more on that. But in this particular picture, that's a Fluke product, that's a Fluke product, that's a Fluke product, that's a Fluke product, those are Fluke products. So we play a really big role in electrical temperature and pressure metrology as well in the laboratory. So we're going to go back to Egypt here and talk a little bit about why measurements matter. So why are measurements important in the world? Well, the first thing is we live in a global economy. So interoperability is really important. If I buy a 5-ohm resistor from Australia, I want to make sure that it reads 5 ohms as I would measure it here in the United States. And actually, the science of measurement is probably one of the oldest sciences that mankind has, because as soon as mankind started to gather together and started trading grain for gold, what mattered? Measurements mattered, because how did I make sure I'm getting a fair amount of gold for a fair amount of grain? So studying the science of measurement and building standards around that was extremely important. And again, interoperability, to have a global economy, you have to have a good measurement system. In fact, as countries develop, one of the first things the United Nations does to help them is they will establish a national metrology institute in the country to help build the system of measurement so that they could do trade with other countries around the world as well. So part of the things that make interoperability happen is traceability. all of your measurements need to trace back to a single definition for the measurement. And we're going to talk about those definitions during this presentation. But we wouldn't want our volt to be different than the German volt and be different from the Japanese volt. We all want it to be traceable to a single reference, preferably a constant of nature, something that's unchangeable as well, as far as physics would tell us today. And then the last reason why measurements matter to me is consistency and quality. In any kind of a manufacturing process, you want to be able to have good, solid measurements to be able to have a good quality process. And I took this particular picture when I was over in Egypt. I was doing a technical assessment for the Egyptian Air Force for their primary standards calibration laboratory, and they gave me a day, so I went out and looked at pyramids for the day and took a picture of this pyramid. But there's a reason why, because it's about quality, the quality of the pyramids. So the pyramids were built with a length standard called the cubit, and this is a partial picture of what that Egyptian cubit looked like. And the key is everybody was given a cubit to work with. All the workers were given wooden ones, some of the managers were given granite ones, and out of that process, everybody was required to bring their cubit back for re-measurement every full moon to ensure that it hadn't worn inappropriately so that they could still build the pyramids correctly. Now the result of that, in failure to do that, not bring it back every full moon, was punishable by death. So pretty solid program. But the result of this is that the squareness of the pyramids are square to within 0.05% or 500 parts per million on each side. And they've been there for a couple thousand years. Pretty solid quality if you ask me. So now we're going to go back to Indiana. And we're here in Fort Wayne, Indiana. And you're at your local grocery store and you want to buy a pound of meat. Okay? Well, what happens? Your butcher puts it on the scale. Well, how do we know that scale is accurate? Okay? Well, hopefully somebody from the county weights and measures department comes in and puts test weights on that scale on a routine basis to ensure that that scale is accurate, right? Okay, but who makes sure that those weights are accurate? Well, down we go to Indianapolis, to the state weights and measures department, where those weights are calibrated by weights of higher accuracy and a better environmental condition. Because every measurement propagates error. You can't make a perfect measurement. Every time that you make a measurement, you're going to have some error out of your process. It's part of the observer effect. It's not Heisenberg's uncertainty principle, but it's actually the observer effect, which means that the properties of trying to make a measurement on something is going to perturb whatever you measure, so that you can't you're not actually measuring the quantity that you intended to do in the first place. The best way to think about that is when you're trying to measure the air pressure in your tires. What happens when we try to measure pressure in our tires? Yeah, a little bit comes out. So we've lost some air, and now we're no longer measuring the pressure that we intended to measure. And so that's error and uncertainty propagates in every single measurement. And to that light, when we're going up the chain from dissemination, each uncertainty has to be smaller and smaller and higher quality because we know it's going to get bigger going down. So again, we calibrate our field weight with a better test weight under a nice laboratory. And again, it's going to go up the chain of traceability to from again where we make measurements up to where that scale might be calibrated by the Indiana State Weights and Measures Lab. Indiana State Weights and Measures Lab sends their weights to a place called the National Institute of Standards and Technology, or NIST. And in fact, Dr. Masters had said that one of our common friends works there in the math department, Zena Gabu. I can never pronounce her last name, but she works and does the calibration of the primary weights for the United States. And of course, those weights, and we'll talk about the definition, go back to the International Bureau of Weights and Measures. They're traceable back there. That is based upon the definition of the International System of Measurement Units, or SI. So, SI, where did it come from and where did it start? Well, the Internet, I'm sorry, yes.
Do you mind questions?
Oh yeah, please. But if you have questions throughout the process, let's just have fun.
Okay, this is going to come out of left field.
It's okay.
Who the hell's doing the damn English units these days?
I will cover that in this slide, but you're absolutely right. That is a great question. I'll tell you, as a United States metrologist, you would not believe how much grief I take from around the world about that. Well, I will to answer your question. So, who is left that uses imperial units as their primary units of measurement? Well, there's the global big three where we've made America great again. There's us, Liberia in Africa, and Myanmar, and everybody else is on the metric system. So, other than that, we're it at this point. But good news on that though. So the whole SI system, the International Systems of Units, was really founded and built by the Convention of the Meter back in 1875. So that's what established the kilogram, the meter, later defined the volt, and the measurements that we use today are based out of 1875.